So what does a data scientist do in practice? Well, first they start by digging around in data, trying to find interesting data to analyze. And that's why I have a picture here of some kids panning for gold, trying to find those little nuggets in a lot of dirt and dirty water. So the next step is that they have to clean and prepare that data, and then they hypothesize a model. So they think about what they think might be some interesting properties of the data and build a model. They then evaluate and interpret the results of that model, and oftentimes you don't get what you expected, and so you have to go back and collect more data and repeat this cycle of cleaning, preparing that data, hypothesizing a new model, or maybe a hybrid of your old and new or some composite model, and then evaluate and interpret the results from that, and then repeat and repeat and repeat until finally you have a model that you think gives you interesting, statistically significant results. And then you want to run that model at massive scale. And so this is where large-scale exploitation comes into play. Now, some of the topics for a data scientist include data acquisition, data preparation, analysis, data presentation, data products, and observation and experimentation. Now, what makes data science difficult? Many things. First, we have to overcome assumptions and making ad hoc explanations of data patterns. And this is just human nature. When we see something, we immediately see a pattern. And it's very hard for us to overcome that pattern that we saw and really understand, was that just something that, sort of like an optical illusion, or was it really a significant pattern? We also have to be very careful about we think it might be this because, those kinds of ad hoc explanations aren't scientifically valid. We also have to make sure we check and we check and we check again. We need to validate our models, validate the integrity of our data pipeline, and so on. So think about the Google Flu Trends results. Initially, they had a very accurate model, but over time, the model became very inaccurate. And this is because the underlying conditions changed. Flu stories appearing on Google News. They had to go back and revalidate their models and revalidate their data pipeline. And then they got great results again. We also have to be very careful about overgeneralizing. That is, taking a model and trying to apply it everywhere. Another hard thing for data science is communicating our results. How do you convey the results of your model to someone who's not a domain expert or who does not understand statistical methods? And related to this is we have to make sure that we use statistical tests correctly. Again, think about the caveat example with Facebook, where the researchers did not correctly apply statistical techniques. Another challenge is moving from a prototype model into something that you can run in production and can actually handle massive amounts of data and deliver results nearly instantaneously. And finally, data pipelines can be very complex, lots of moving parts from many different projects and sources. And so when something goes wrong, who do you ask for help?